This is the solution for station number 5. I can name ternary ionic compounds from its formulas. At this time, you may pause the video to check your individual answers. Or you may continue with this video to hear the individual explanations for each of the problems. Looking at the given formulas, you will notice that the metals are written first, just like the binary ionic compounds that you've worked with. However, unlike the binary ionic compounds, the anions are not of simple atoms or elements, but rather you now have polyatomic anions that are bound to the metals. The names and the listings of the polyatomic ions are found on the back of your periodic table. Your periodic table is not only available for your personal use for homework and in-class work, but they will be provided during exam. There will be no need for you to memorize. Rather, there will be a need for you to recognize, find, and name and note their charges. The naming scheme is pretty much the same as the binary ionic compound when it comes to the metals. You write their unaltered name. So in this case, Al, aluminum, will be written first, just like binary ionic compound. Unaltered stays the same. For the name of the polyatomic anion, OH is what you're looking for on the back of the periodic table. In that listing, on the -1 column, you'll notice that the hydroxide is what you will find. So the name in this case becomes hydroxide. Continuing with the second substance, again I have a polyatomic ionic compound. Ternary, that is. When I look on the back side of the periodic table, I'll notice SO3. This is sulfite. However, I do remember about the iron along with the other metals that have multiple charges. In order for me to determine the name of this particular substance, I need to understand what charge this substance is to determine if whether or not iron is +2 or +3. When I look in the back side of the periodic table, I notice that sulfite here is -2 in charge, which means that if I have 3 of these, that would give me a total charge of -6 as a sulfite. Iron, on the other hand, I see that it is 2, meaning I have 2 of iron. If the total charge here is -6, then the total charge on the positive side must be +6. Seeing that I have 2, that means individual iron must be +3 charge. If this is the case, then I have iron, and I do write this first just like before, but in parentheses I must note Roman numeral 3 to say that it is iron 3, not iron 2. The name is sulfite as we found it on the back of the periodic table. Okay, so this will be iron 3 sulfite. If I look at the next substance, I have copper and phosphate. Just like iron, copper is one of multiple charges. Looking at the back of the periodic table, I'll notice that phosphate is -3. And I have, in this case with no parentheses, only 1 phosphate. Which means that the copper here has to come out with +3 charge. Knowing that I have 3 copper, that means individually every one of these have to be +1, because 1 times 3 will give me +3. Thus balancing out the charge of phosphate, which we have saw in the back of the periodic table, it is -3. So the name in this case, unaltered, copper again, but because of the multiple charge, we will use parentheses to indicate that it is of only 1 charge, Roman numeral 1, and then use the name phosphate, which is what we found on the back of the periodic table. The next substance I have here is SR with the substance that I found on the back of the periodic table with a -1 charge. This is acetate. Strontium, unlike iron and copper, does not have multiple charge. It's a group 2A. There is no need for Roman numerals. So the name will be unaltered without any parentheses, and it will be simply strontium. And then I will finish this up with the word acetate, because that is the name of the anion that is listed in the formula. The next substance here is AgPO4. Silver, although it is a transition metal, does not have multiple charges. Thus, it does not require any Roman numerals. If I look at PO4, which is on the back of the periodic table, just like the one that you did previously, this is phosphate. So the name here will be simply silver phosphate. Moving along here, I now have the next substance, which is MnO4. And then I have potassium. Potassium again is a metal that is only one charge, and thus I do not need Roman numerals. When I look in the back of the periodic table under -1 column, MnO4 is manganate. So in this case, the substance is first the metal, which is potassium, so it will have unaltered name, so potassium is written first. And then you'll have the name permanganate. Okay, it is a long word, so we'll make it fit. Okay, potassium permanganate. The next substance I have here is COCO3. Cl is one of those metals that have multiple charges. It is those that we need to be aware of. And because it is one with a multiple charge, I must look at this CO3. It is carbonate, found in second column with -2 charge. If carbonate is -2 in charge, that would mean with the ratio of 1 to 1, because there's one of each, that cobalt must be also of +2. That is the only way the charge will add up to be 0. So in this case, I would have cobalt, and yes, unlike the others that have only one designated charge, I will need to use Roman numerals, and I would put cobalt 2. Okay. Cobalt 2 with the substance which is on the back of the periodic table, which is called carbonate. Okay, so that would be cobalt 2 carbonate. Okay, I'm going to fix up the A a little bit. Alright, next substance is tin, and NO2, which is nitrite. Now, I need to consider tin a little bit more. Just like cobalt, it has a multiple charge. Thus, I must look at my anion, the polyatomic ion, to see what that charge is. Nitrite is -1 in charge. And because it's -1 in charge, I need to look at the subscript, which tells me that I have 2 of these. So the anion portion in total is -2. Thus, tin with only 1 as the atom itself, or the ion, means that as a total this must be +2 in charge. So tin being +2, I will write its name, and then using Roman numeral I would write 2 for its +2, and then follow through with the name that I found on the back of the periodic table for NO2 minus, which is simply nitrite. It is not nitrate because it would be NO3 before it would be nitrate. It is NO2. This concludes station number 5. If you have any questions, please ask by raising your hand.